Hello, my name is Martin René Andersen and welcome to yet another C++ video. Yay! This time it is a slideshow consisting of 10 different images I have created the last couple of years as examples to show 10 different point processing transition. I will first off just show you the 10 images and then I will be quiet while you're watching. And right back to the beginning. Yay. Then I will now show you how I did the different transitions, and while showing I will try to show you, or like before I show you a transition, I will just showcase it here to the right so you can follow along. Maybe a bit hard to remember all there is. But this is created with openFrameworks. So we have here our test app.h, which consists of all the variables I'm going to use, and I'll just go through these quickly. I have an openFrameworks image, standard openFrameworks stuff, one for each. 10 image I have. I could probably create a loop somehow creating these, but then I have a texture, and I have an integer for total pixels. I have an unsigned char for my data, an integer showing my current picture, an unsigned character array for which will contain my images, a counter, an integer, a float for the alpha. I actually don't think it has to be a float here. Oh, it does, sorry. I just forgot I had my fade. And then I have two integers called animation state and animation state 2. I use these specifically for some of the calculations in my transitions. And here lastly I have a vector. And for those who do not know what a vector is, it is kinda like an array, it just has way more features. And this one will contain integers. And let's get back to the actual code. I first have loaded in all images. I could probably have done this a way smarter way, but this will work. I'm setting my background color to 0, setting my current picture to 0. Oh, I did that twice, no need for this. Load in all the images into my array, so it's easier to refer to them. And then I allocate texture space. Yay. My slideshow is 550 times 40. 400, and it is red, green, blue. And here I'm just setting a lot of my variables to 0 before we start, and I'm calculating the total amount of pixels. Or actually not pixels, because this would be my amount of pixels, but because I'm doing this with red, green, blue, I have to time it with 3. It contains all information. And data is just set as a new unsigned char with the amount of data we need. Let's get to it. My stuff here works pretty simple. I have a counter. It counts to 500. In the end of my function, I am counter plus plus. I'm setting one more to counter. So every time counter reach, here we go, 500, it will set the current picture one up. It will reset all the stuff I need for the next transition. And this was just for debugging, don't need that anymore. So this is just resetting everything and telling me next picture please. Then in order to know what transition to do, I'm having a switch case with the current picture modulus 10. For case 0, it is the alpha fade. Let me show you that quickly. Starts right off, changes one picture to another. What I'm doing here is simple. I'm changing the current data to my first picture, the second picture I start with, times alpha, plus the old picture, 1 minus alpha. Which just means the old picture is the one fading away because of this. And then here is how quickly I am doing this. So this is going to take bit of time, 100 frames, in order for it to be done. And I'll just showcase these during the way. So I'm changing those to 0. Let's just copy paste, it'll be faster. Then I have an alpha which takes red, green and blue in order. Let me show you here quickly. So just take notice, it first takes a red, then green and then blue. Open that. Let's see, here we go. Red, green, blue. And we could remove this again. Apparently that one didn't like being first. I do not know why. Don't know, bother looking into it right now, but what this does is pretty simple. I have animation state for use in this one, and this one is just going to give me 3 different states. Let's see, first off we're going to run a for loop. It goes not through everything, but it goes through total pixels. In this case, because animation state is set to 0, we're going from 0 all the way to total pixels. But we are only taking every 30 pixels. We are only taking all the red ones. And then we're doing the same exact fade as right above us. Then if we're done, I'm also doing this a bit quicker. Double the speed, because I have to do this 3 times now. I just thought might speed it up a bit. But still not so fast that you do not really realize we're doing this. Because I kinda like the effect it makes. But first off here, we will see that as soon as we're done, saying if we are not below what we want anymore. Also, I'm not setting this to 1 because I was really lazy probably and did this to fix the error so it doesn't go above. I could have done this way smarter, because right now it stops at, I guess, right below 1 and not exactly at 1 as I would have wanted. But when it's done, I'm going to take animation state up to 1 and resetting alpha. So it runs through this again, but this time it doesn't start at 0, it starts at 1 and again takes every 3 steps over 2 each time, meaning this time it's only changing the green values. And then we do it again, and this time blue. Once again I'm setting animation state plus because that doesn't really matter. It's not going to do anything now until the code is done, and we're going to the next one. Let's see, scrolling. Let's hope this one doesn't bug when being the first one. Here we go, and you can see our elephant scrolling right by. This one is somewhat simple as well. We once again use animation state But this time for something totally different. This time using it for how many, well, pixels it is supposed to have loaded when it does this. So at the end every time I'm saying plus 3600. I just messed around until I found a number where I like the speed. I still think this will highly change the amount of pixels it's loading. But for doing this I would highly recommend doing so it fits with a line. Especially if you want it to be like scrolling. And so there I'm going from 0 up to how many pixels are supposed to be loaded, put them right in, and then I'm going through from where we left off to total and just fill in with the rest of the old picture. I guess I could have just started off saying I want the old picture and then start overwriting, but I'm not exactly sure what is faster. I haven't tested it. Then we get to one which is more funny. Random. Let's see here. I really like this one. Here you go. It seems like it's just crumbling away. And this one is a bit more advanced, especially if you're new to the C++. And I'm doing some horrible stuff, I guess, here. But first off, I'm setting my current picture. Then we'll start overwriting it. And then I have my animation state once again. And this time again for a new purpose. Because the first thing here, I only want this to be run once. And this is basically why I'm doing this. So, in this first time I run it, I'm going through from 0 to total pixels divided with 3. So this time I actually get the total pixels. Way. But I'm filling a vector, which I said earlier is pretty much like an array. And I'm filling this with all the values. Push back simply means I'm putting them at the back of the vector every time. So I now have a vector filled up with all the values. Then I use random shuffle. And random shuffle is a part of the algorithm library. And what this does, here we go. And this does, it has two different ways you can use it in this vector. You have to give it the start and the end of the vector, and then it will randomize the order. But what I figured out, it is not totally random, just as if you're using the random standard function. It will give you something which is always the same order every time you do it, unless you do the srand, and I was too lazy to put that in because I like the result here. But what I did figure out, as you will see in just a bit, is that random shuffle was not that random. It really wasn't. It was only taking chunks of the code and rearranging it looked like. So instead of really fixing this by giving it what random value I want, you can specify it somehow. But I just felt like, let's try and copy paste, and that worked fine. So I was fine with that list to understand of this algorithm. And then I set my animation state to 1 because I will only run this once. And resetting alpha, which I guess I don't need. Why do I have that? Why? And then case 1, and this will run just as many times as needed. This will have a for loop. It's running from 0 to alpha. And alpha is every time plus 1000 until it hits max, and max is the amount of pixels. So this once again just is how many things it has to be with the new picture and how many with the old. Then I'll loop through from 0 to alpha. I could have used my animation state too, but I think I made that one later because it's kinda confusing. I'm using alpha for something which is not alpha. I'm sorry. It was just to get an integer value. But then I'm going through everything here times 3. And I'm setting it to the old. And by the way, I'm doing times 3 because I've divided everything. with 3, so if I did not do that, it will only do third of the picture. I'm going through everything, sending it to the new picture, if it is in this random order. And then I do it twice with -1 and -2. And I do this because I wanted it to be done with pixels. If I didn't do all this, didn't divide by 3 and all that, it will take each time a color and not a pixel. So we get this rainbowy spots everywhere sometimes, which you will get to see now anyways. Let's remove this and show you my random curtain. My rainbow curtain. But try to see here, this I'm not randomizing it as much, and I do not care about pixels this time. You can see here it gives this rainbowy colors, red, green, blues. And it came from top to bottom, which was what I realized up here before and why I just did it many times. So here I'm only doing it once. But other than that, it's the same. And I do not care about pixels and colors here. I just give me everything, all data, and do it one at a time. So we get this funny trace behind where you see it's not totally done. It has only maybe been at a pixel once, so it only gives this bright color left. But other than that, it is exact the same as what you just saw. I just thought it was funny to keep this one, but I was trying to achieve this one when I created it. I just thought I'm going to save this. I really like it. Then we have fade to black, and then to the next picture. So you will see our turtle fading to black, and then to my elephant. Black elephant. Yep. And this one is really simple. It is based very much on the first fade I had, and just with the thought that if I want something to fade with black, it's just remove half of the equation really. So I do this, but I also have my animation stage once again, and I have it 2 stages. I have one where it has to fade to black, and then one where it fades from black. And I just removed half of the equation, set them so it's to black and not to another picture. So that one is simple. We have scrolling left to right. Let's see. You can see here it just the top picture is sliding off. And this one was a bit more complicated for me to find out how to do and figure out. But it was a lot of messing around with it. Once again, I have animation state for how much has to be pushed away. Once again, I'm sorry that if this one is hard to follow, because for me it was hard to understand as well. But what I'm doing is I'm looping through all pixels again. And first off, I'm going to say data I plus animation state, which is right now pixels plus 6. I had to make sure it was something which could be divided by 3. How do you even say that? The free table. I don't know, sorry. But to make sure it was pixels, and that it will give this. If it was like 5, you will see a lot of color changes in everything, because it would be offset. Basically, I have a max of my width of the picture. This is the width 550 times 3 for the RGB. And then, which was the complicated part, was figuring out how do I have the image beneath it. And here I found out I could use modulus. I modulus 550 times 3, and also it has to be smaller than animation state. And we delete that, and I have to close this down from top and bottom. This one is based on the first one I had, but it just came from top. I just added it, doing it from the bottom as well. As you can see here, once again I'm doing this, but well, same spade axis I think. and this should be exactly the same. Oh sorry, wait, this one. Sorry. Just taking it from the start and down. Except here I'm just using twice because they're going to meet at the middle. And then in order to get it from backwards, I'm doing the exact same. I'm just saying total pixels minus I. So we take it reverse and fill it up. This one is simple. Just have to create the top one and add bottom to it. Then we have sliding in from all sides. It's the same again with even more. This time both right and left is going to slide by. This one required a bit more work. Because once again here, exact same as up here. But let's see, what do we do? We start off saying bring in the old picture, and then we add top and bottom, and then I had to really think how come I do it from left and right. This one is for the left and this one is for the right. I need to write that. Left, right, never forget. 1650, that is the same as 550 times 3. For some reason I didn't bother writing that this time. But really what I'm doing here is I figured out 400 is my height, by the way. So I'm looping through the height, so I'm getting all pixels, and then I'm looping by 3, and I do this in order to get, once again, so I don't get these color changes. It's for the pixels, so I take one pixel at a time, and then I'm using animation state once again to tell me how far I am. So the equation suddenly gets a bit more messy. We have the width times the height of where we are right now in the loop, so we get every line plus how far we are, and then because we have looping through, we want every pixel plus O. And then I have one where it's reversed, minus minus instead of plus plus, to get it from the right. And then we have the last one, and this one is a bit funny. Let's see here. It is going to give us random again, but this time with lines, giving us random lines filled in. So this one is based on the random ones I did earlier. I just changed them slightly. So first off, I am putting in the old picture. And still I'm not sure if this is faster than the other way of doing it, by doing it after I have added in the new one, which is how I would prefer to do it. Then I have my animation state, because first I figure out a random sequence I want to do in it, and this time I'm doing it with 200, because my picture is 400 height and I want the lines to be 2 pixels high. So I'm just taking half that, 200. And then I randomize it just once, because this time you will not really see there's the pattern. And then I'm simply going through them all, and with the knowledge I had from before how to do the height and width and such in a more advanced for loop, this one was pretty simple to go by. We're doing 550, which is the width, times 6, and we do this with, well, why am I using alpha again? I should be using my animation state 2 thingy. Nah, pfft. But times 6 because I want it to be 2 pixels high. So by doing this, it is the same as saying 3 times 2. This would be the width, and this would be because I want 2 width. So 1 line, and then I'm simply filling in all the lines which has been determined by the sequence and how far we are. So I'm actually just adding 1 line every frame. And then at the very end, so this one's for no matter what image we add and what transition we're doing, we load our data, our current picture to be shown, into our texture, and then we draw it. I choose to draw mine in 150, 150, so I get this 150 border Let me show you quickly. As you can see, there is. Okay, you stopped working, but oh, I guess it's my screen recorder fucking things up now. But what I do have is I have 150 around all the picture, and it's because I in the main CPP made sure this would also work fine with the size of the window. And that should have been everything. I hope it was somewhat able to understand it. A bit rushed, sorry. I hope you enjoyed the video. I was Martin René Andersen, and have a good day.